Okay, I was asked to make a quick video on one problem like you might see on your quiz tomorrow. Okay, first we look at our problem and we're going to find our real zeros. And we're going to write our zeros and factors. So, first step is to do Descartes' rule. Okay, so I'm going to, let's see here. Start off with my little table of positives, negatives, and imaginaries. Okay, and sign changes. Positive 6 to a negative 25 is 1. To a positive 24, that's 2. And then positive 27, that didn't change. But when I go through positive 27 to a negative 18, I have 3 sign changes. Positive to negative to positive to negative. That's 3. And then for the negative sign changes, I would have to change the odd ones. The odd exponents. So now positive, positive, positive to a negative, there's 1. Alright, so now I'm going to finish my table here. And I'm going to get, let's see, how about 3, 1, 0, because I'm trying to add up to 4. Or this could be a 1, 1, 2. Or a 2, 0, 2. And are there any other ways to make this work? I don't think so. Double checking, one. Okay, let's go with that. All right, now I'm going to start guessing. And I'm going to guess, let's see, how about numbers that go into negative 18. Let's see, 9 goes into negative 18. I probably wouldn't start there, but I'm just doing it to show you what would happen. At 1, 2, 3, 4, 5 terms, so 6, 25, 14, 27 and 18, negative 18. So this is 6, 54, 79, and you can see that it's going to keep getting bigger and bigger, and then I'm going to get a number so big that it's going to cancel out this negative 18, so all of them are going to be positive, and I happen to know that this is not going to work. So since they're all positive, that means 9 was the that guess was too high. Okay, so I won't do that again. All right, so let's see here. All right, let's try. Let's get my table back. Positive, negative, and imaginary. Here was 3, 1, and 0, 1, 1, and 2, and 2, 0, and 2. Alright, so I'm going to try, let's say, how about a negative 1? So 6, 25, 14, 27, and negative 18. Okay, and then I'm going to try a negative 1, I said. And I hope you realize by now, whenever you watch me do this, you want to jump in, then pause the video, work it out yourself, and see if you can finish this problem with all the answers. So here's a 6. This will be negative 6. This will be a negative 31, positive 31, 40, 5, negative 45, 18, negative 18, positive 18, 0. Okay, that one did work. All right, that's a 6. So we found one negative, so we can eliminate this one here because we found a negative. So it has to either be 310 or 112. Okay, so let me go back here and go to my black pen, and we're going to continue from here. So I'm going to try, how about, what numbers go into this 18 that I have right here? 18, how about 3? I'm going to try 3. So 6, 18, that gives me 3 and then 1. So this is negative 39, which will give me a 6. And this will give me a positive 18, and that's another one. Okay, so now I know 3 works and the negative 1 works. Now I'm either going to have 2 more positives or the other 2 are going to be imaginary. And then this top row, this original one, was to the 4th. That means the quotient here is to the 3rd, and this quotient on that one should be to the 2nd power. So I know this is going to be 6x squared minus 13x plus 6. Hello. So we're going to factor this, and here is that factoring method that some of you may remember or you don't remember, whether you were taught in Algebra 2 or Algebra 1 before. You take the 6 at the beginning and the 6 at the end, you multiply those and you put that on top of your x, and you put negative 13 on the bottom. And then you would figure out what 2 numbers multiply to 36, and then added together gives you a negative 13. So it looks like maybe, how about 9 and 4? Negative 9, negative 4. That looks like that would work there. And then, since I multiplied by 6 to start with, I have to divide both of these by 6. And I reduce these, so I'll get a negative 2/3. And then this is a negative 3/2. I'm running out of room here. But that means that this is going to factor as x minus 3 halves, and we don't ever factor with fractions, so we're going to put that 2 in the front, and then this is x minus 2/3, and then put the 3 in that front. Okay, and these are going to be negative, right? So if you're solving these using the zero product property, right, you would have to add 2, and then divide both sides by 3, and then you're going to get this, except you're going to change the signs on that. So that that factor is going to be 2/3. And this one, you make that equal to 0, and then you add 3 to both sides, and then you divide by 2, and that's going to give you a positive 3/2. So there are your 3 roots. Negative 1, positive 3, and by factoring, or you can use the quadratic formula, positive 3 over 2, and then positive 2/3. Okay, so your factors are going to be f of x is equal to x plus 1, x minus 3, x, or actually 2x minus 3, like I had down here, and then the last one will be 3x minus 2. Okay, I wish I had my tablet here. That would have been much neater. So those are my zeros, those are my factors. Now I'm going to have to graph these. I've found the zeros. I wrote them as factors. Okay, I found the zeros. I wrote them as factors. Now I'm going to graph it. Okay, I'm graphing it. And go to the next screen here. Okay, my factors were -3, -1, 3, -1, 3, 2/3, and 3/2. So on this graph, I'm going to put a point at -1, one at 3, and one at 2/3, and one at 3/2. Okay, and since this is even and positive, I know that the endpoints are going to look like this. And since I told you that there is a maximum at 1/6, I'm going to put a point there so I can hit it. Approximately right there, there's a maximum. So I'm going to go through here, hit that maximum, come back down here, go through here again, and that will be my graph. Okay. Just so that you know, if you had, let's say, let's redo this here. That's the whole problem, but let's graph a different one. Let's see here. Erase ink. Let's say instead of this function here, we had -3, -3, 2, and 6. Let's go one more. How about 8? All right. And because this was a positive function, and there are 1, 2, 3, 4, 5 roots, so it's x to the 5th power, and it's negative, and there's some number here that I don't really care about. So I know that it's going to go down to the left and up to the right, and it's going to have -3, +2, 6, and 8. Okay, so it's going to go bounce off of the -3, go through the 2, down through the 6, and back up to the 8, and that's how you draw that one. And because there's an even number, okay, it goes through the 2 because there's only one, it would go bounce off the -3. If there was another one, now it would go through because now there are 3 -3s. If there was another one, then it would bounce off. Another one, it would go through, and another one, it would go bounce off. So even number of zeros, it would have to bounce off. We call that a multiplicity. If the multiplicity is even, the graph will bounce off. If the multiplicity is odd, it will go through. All right, that's it. I want to keep this short. I wish I had my tablet so I can write on this much better.